Welcome to Chip Logic Studio. In this studio, we will discuss about I2C protocol, how to design I2C protocol duty, and in future we will verify this duty. So, for the designing I2C protocol, you should know some basics. So, first we will know what are the two types of protocols. One is parallel protocol, another is serial protocol. Parallel protocol is also called bus protocol. As a bus go from one place to another, this bus protocol also travels data from one place to another. You have heard about APB protocol, number protocol, bus protocols, which is used for transferring data from CPU to memory, memory to any other thing. But I2C protocol, serial protocol, SPI protocol is used to communicate between two devices like ADC and DAC. There are frequent communication between them. So we are communicating with these protocols. So there are some differences. For example, communication type is parallel serial, that's 1 by 1 bit in serial protocol, and parallel protocol directly transfer multiple bits. And device supports multiple devices. It also supports multiple devices, but major cases point to point like ADC DAC. An example I have told you, number protocol and I2C here. Speed can be vary as per the application, but parallel protocol is faster because it is parallel now, so multiple data can transfer from multiple lines. And here, but in bus protocol there is specific function for handshake and everything, but serial protocol vary in these things. So let's move to I2C, our main topic. So I2C is synchronous protocol, means it has a clock to synchronize it. Multiple master, multiple slave, we can connect and communicate between them. Designed by NXP, low speed peripherals, and that's about it about the introduction of I2C. But what we will see here is our two major things. SCL means clock, which will synchronize it. It is only one directional. And next thing is our SDA, means data line. Bidirectional means data will be sent from master to slave, and data can be come from slave to master. So bidirectional, but at one time only one direction will be followed. Here is our basic how the two lines can communicate between the two things. So we need one start condition for saying that the protocol has started. We are sending the information and stop that we have get the information. So these two conditions are made by the two data lines, one data line and one clock. SDA data will be at low and go from high to low, and SCL also go from high to low. Then only the start signal is there, and when they go from low to high both at the same time, then it is the stop signal. So this is all about how the protocol start to communicate. Here is the waveforms, you can refer it. Now this is the main thing. We will design our protocol with these things only, and this is only needed things for designing a I2C protocol. So first, how much data can it send and how much data can it receive, how it's do acknowledgement. So this is all things which is covered in this slide. So address frame has 7 bits or 10 bits, depends on the address. Consider 8 bits, and in 7 bit plus 1 bit we will consider a 7 bit for address and 1 bit for it is writing the data or reading the data. So it is total 8 bits, and this plus one acknowledgement and not acknowledged signal will be there, that our data is sent and not sent, something like that. And 0 will be for write and 1 will be for read. And data frame is also 8 bit. 8 bit data will be sent, and receiver will send acknowledgement or not acknowledged. If master is sending data to slave, then slave will say acknowledged, not acknowledged. So as we studied this high to low start signal, then SDA will go low, SCL will start to clock, and this 7 bit will be address which we will send, that in this address we are storing the data, and read and write signal we have to store or read the data, and then acknowledgement that our data is sent. This is our data. Then we will send our high signal, and this is low signal, means that one frame is done, Okay, next frame is data. One packet is done, one next frame is data, 8-bit data from D7 to D0, and again the clock will start. As per the clock the data will be sent, and again the acknowledgement that I have sent the data. So we will stop here. And what is the stop? Low to high. So this is all we need for designing the I2C protocol. Here we are not using FSM, we are just using this address and data frames to designing our I2C protocol. There are different speeds of I2C protocols, and we are only speed mean modes, so we will only concentrate on one mode, that is 100 megahertz clock. Means as per the clock the speed will vary. So if you understand one mode, you can design on the other modes. So let's start with design. And this is our main clock, 100 megahertz, and input is data, our 8-bit data input, and address is also 8-bit, but 1 bit is for redundant. Okay, now this is our FSM, how our signals are there, how the data is transferring, what is the condition for reset, all of the things is considered as FSM, right? And state machine. So first we will go for idle state, then start init, then start initialize means init. Okay, so let's start. And here state is there because we have used parameters, and this parameter is state, which is of 4-bit, and idle is our first condition because every protocol, every FSM start from idle condition. Here SDA and everything is 0, so initializing all to 0. These are the modes: mode 1, SCL mode, SCL toggle mode, but we are not using this for now. And I have edited the code that this will not be seen in our episode. Sometimes there may be, but you have to ignore it. And our data, this is internal segment, we will store data temporarily in this address and data store and read store. Okay, now we will start our storing of data. This is our input signal which will be given to the I2C protocol. The store, then this will be storing address to send store, data to send store. So at this sensitivity list, whenever we get the data, we will store it. Okay, now first we will send the data with 0th position of index. Okay, let's start with our direct code. This is all about modes, so just ignore it. So always at the clock 100 megahertz, which is our standard mode, and here is one counter defined that how much time it should stop. And for synchronization, like you have seen in address line, that at the some time it stops, that the address is completed, so that what it is doing. And this is the cycle, that if 8-bit is data, then it need 8-bit for transferring data, and for total sending the data we need 24 count. Okay, so this is all about mode. You are not seeing this log to me. This is our FSM where we start. So if reset, our state will be idle. That's the obvious, that reset will set our to the idle condition. Now let's start idle condition. What is idle condition? Mode will be 1, standard mode we are using. Other mode is also 1, but we are not using that. And address sent to store means if here the data came, here it is, this, if here the data came, it will be stored. And when this data is stored, we get the data, we will set our state to initialize the start, means when we are going high to low, that is our start condition, high to low. So again mode will be 0, means first mode, standard mode. First the mode was 1 because we are yet to transfer the data in idle condition, but now we are sending the data. So it's all, the start initialize mode is all about the selecting the mode and then go to the next state. So start will start our sending data, means state will change, that okay, we will go from high to low in SCL and SDA, because all are 0 now, high to low, that is our condition. SCL and SDA is high and then it is going to low, this is our condition for start. Now address, because we are saying this is, I committed it is all over mode. Now we are not using this toggle mode as well. Okay, I will comment it. Now address data, address send. So address is sent by bit by bit. So as SDA line is sending 1 by 1 bit, and SDA you can see it is only 1 bit. There is this SDA 1 bit. So we are sending data 1 by 1 bit until the bit count is 0. If the data is sent all the data, then slave acknowledgement initialize means acknowledgement signal should come. When the acknowledgement signal will come, then we will go to the slave acknowledgement, means it is initialized. We are waiting for that acknowledgement, and then as I said, we are waiting for that, and we get our acknowledgement signal. So now we will decide if we have to read the data or write the data. Here 0 means read the data. Okay, so acknowledgement is came, and we have sent our address that we have to write or read the data at that address. So we will see both the conditions what we have to do, and it is set for 4, means we will have to decide now after address there should be some delay to differentiate between data and address. So that is the count. Now data send initialize wait means we will send our data now, and that also we will send by bit. Okay, now SDA mode is our standard mode. Now state will be data send initialize, means we are initializing which data we have to send now, and all the conditions are met, acknowledgement is met, and now we will send our data. Now send data means directly state change to send, initialize the send, that we have get our acknowledgement, your mode is changed to 0 means start signal. This is the start signal, that low high to low, 1 to 0 start condition again. Then data will be sent here, and data will be sent by bit. Okay, so until the bit count is 0, data will be sent, and data acknowledgement we will need now acknowledgement. So we will wait for acknowledgement now. Then if we get acknowledgement, then we will again send, means this was for write data, and this was for read data. For write data we are sending 1 by 1 bit. Here read data we are only just reading the data. Okay, bit by bit we are just reading the data, and when our address is sent, then our data is sent, and we get both acknowledgement. We will stop that. Okay, master has sent all the needed things to slave, and we will stop here. So we have to wait for acknowledgement for data from the slave, that okay, stop. So we will stop. Now low to high is our condition for stop. So the signal will be low because we are transferring data, then it will go to high. We stop. This mode we have to ignore, but this mode is low to high, means standard mode, 1 mode. Okay, so this is how we design protocol. If you create FSM first, then you will design it, then it will be easy for you. Okay, thank you. We will verify this, and all the verification components are ready, and I have to take a longer video for explanation of this, so hope I will make the video soon. Thank you.
Дикая шайни, пару лямов money on my neck of money.
It's my name, это мой money rain, no pain, no gain, иди нахуй Monday. Raise my name, right at that pain.